Hi, my name is Devin Gaffney. I run a company called International Persuasion Machines here in Portland, Oregon. And we work at this sort of intersection between security, trust and safety, and influence operations, misinformation, abuse, those sorts of things, manipulation by bots. So I'm here to talk to you about reverse engineering how WAFs like Cloudflare identify bots. The basic wager of IPM is that there is this turn towards a sort of socio-technical security that's happening in the next few years. That is to say, as systems have become more participatory, where the importance of people interacting with one another is the most important thing that's happening on a system, there are these new incentives for exploits that start to emerge that aren't purely technical in nature, but instead rely on hacking how we perceive these systems and hacking how people interact with those systems in a meaningful capacity. That's sort of this umbrella way of thinking about, the Twitter election misinformation stuff, right? This is a socio-technical security problem. It's not just a security problem. If you want to talk about different types of frauds, there's a huge ad fraud business out there. Uber spent, I think, $150 million buying ads, and they stopped spending 100 million of it, and nothing happened. So no, there was no drop in like their ad, whatever their effective reach with the ads, because the rest of that was just being soaked up by bots clicking on links to make it look like lots of people were looking at things and make everybody on the team feel good about themselves. So this is sort of this weird nebulous space where our expectations about how machines work and our expectations about what we are going to get in these different online social spaces can be sort of hijacked. Also, there's this great paper that is, I think, the only paper that sort of like talks about this in specifics. And here's a like heavily edited little quote from a very long paragraph about the sort of introduction to this stuff. So there's a lot of different examples that you see out in the world, fake Yelp reviews, fake Twitter profiles, Cambridge Analytica shit, stealing data and then exploiting it, people using different bots to put comments on Amazon reviews, people doing anything related to NFTs, anything related to crypto. You see lots of different pump and dump schemes where the idea is you have masses of real genuine people bidding on real genuine products, and then all of a sudden once you've bought the thing, that whole crowd disappears. So one of the basic tools that people use to stop bots out in the world is web application firewalls. There's companies like Cloudflare, Perimeter X, which I think got bought by Human last week or something, Imperva, a bunch of these different companies that basically do the same thing. They produce this little page that says, hey, slow down, wait a second, I think something's a little sketchy about you. Maybe it's something about the browser settings or the fact that it's coming from some data center IP or whatever. And there's this whole industry of folks that are building systems to circumvent these tools and try to get around these walls at the minimal cost, minimal effort to them, because they are also engineers that also have access to, Stack Overflow and still have salaries and, budget constraints and JIRA tickets and all of that sort of stuff like anybody else, right? And so they're just trying to find the cheapest way to get over the wall. And so if you go look at packages that are used to circumvent this stuff, you can actually learn a lot about what they're doing, what they're building. You'll see popular URLs show up. You'll see a lot of NFT references, people packaging in MetaMask to open up wallets, stuff like that. And so the way that people use WAFs in practice, at least from my perspective, has been to sort of like be a security theater and throw up some sort of wall that demonstrates some amount of capacity for preventing this sort of bad behavior. But because these are really complicated tools that look at a lot of different signals, with enough effort, you can usually get over the wall and get into the system. And so usually this sort of like one-size-fits-all approach doesn't actually solve anything if someone is dedicated enough to get over this wall. It's mostly a question of, do they want to spend the time doing it? So I did a statistical test a while back where I wanted to know what makes these WAFs tick. So the basic idea is at IPM, we've got 44 different types of bot implementations that use like a spectrum of sophistication. So is it just sending off like a really low effort HTTP request in Python, right? And it doesn't do anything. It doesn't even change its user agent. It's just, let me go to the URL, right? And let's see what we get, right? And that's all the way out to much more complicated things that are, trying to obfuscate the fact that it's a fake browser that's running an actual browser rather than an HTTP request. It's able to execute JavaScript. It's able to detect if it's getting hit by a CAPTCHA and then solve the CAPTCHA, all of that sort of stuff. So with all of these different design implementations, we can sort of label the 44 different types of bots as to whether or not it has that particular configuration of design implementations present. So is it rerouting its traffic through not a data center IP? Is it running an actual browser or not? Is it trying to hide the fact that it's running a browser or not? Or is it trying to hide its user agent? Is it actually mounting the browser on a display or they're called virtual displays, it's headed mode. I don't know how much everybody is read into like playing with Selenium and different types of browser automation tools, but there's one way that you can run it in headed mode to make it look like it's actually on a screen rather than just on some Ubuntu machine out in some vast data center. So we can take all of these 44 different bot implementations and encode them as the different types that they are. Then, there we go. So in order to test this WAF project, what I needed now was a fairly representative data set of different websites that are high profile enough that they are actually using WAFs in a considered way. There's probably a person or 5 people thinking about how it's set up at these companies. And I wanted it to be something that people are actually making an effort to protect. And so what I started with was just a set of retailers. There was this, and also a set of URLs that was like very easy to get because it's a pain in the ass to go look up URLs for 1,000 different companies. So there was this great data set that Newsweek put out of 200 different companies that had all the URLs in it. So I grabbed all the URLs and then I threw them into our tool and then took screenshots and a bunch of telemetric data off of each of the websites. And then now I had this data set of 44 different types of bots hitting these 200 or so different websites once each. Then what I did was I encoded a machine learner that would then look at the responses from these servers and say, is this response from a web application firewall or not? So does this look like I got hit with a wall? And the way I did that was going through and voting on a lot of cases manually, doing maybe about 1,500 of them manually, and then projecting the rest out, cross-validating and making sure that I didn't screw it up too bad. And it was, pretty accurate in pulling this out. There's only a few of these sorts of, large web application firewall companies that do this stuff. So the machine learner was, specifically looking for, what's on the page. Is Cloudflare DNS stuff on the page? And that's pretty good signal to get most of these. And so then I took that data set and encoded it into whether or not I think it got hit by a web application firewall according to this machine learner, and then whether or not different design patterns were present in that particular test. So for this test, using a standard Selenium instance that went over to Patagonia's webpage and didn't try to hide its IP, that's a particular configuration of design patterns. And did we get hit with a web application firewall wall or not? Did the machine learner think that we got hit with one or not? And so we run through that, and we have this really nice data set now that we can throw into this other process. I apologize, this is a very big Rube Goldberg machine to try to get a reasonable answer out. But we can then take that and throw it into a thing called dominance analysis, which is basically saying, all right, so the thing you want to know is whether or not you got hit with this web application firewall. And the things I know that could potentially predict that is, are you using a browser? Are you trying to hide your IP? All of that sort of stuff. So I'm going to test each of those things individually and then test them with the rest of them and see how much lift a statistical test would get by having that thing included in the test. So is this thing actually the thing that's driving it? Is it mostly about the browser, or is it mostly about the IP, or is it mostly about these other factors, right? What is driving any sort of meaningful description of whether or not a web application firewall is actually blocking some of this stuff. And so you can then get a sort of weighted ranking of what things matter and in what order. And that gives you, really interesting information about how people usually are building these things, when they're playing with thresholds, what type of thresholds are they tweaking the most, which ones matter, which ones don't, all of that sort of stuff. So if you're on the defensive side, this is useful to think about in terms of what is someone going to build next? What's their immediate next step? The lowest hanging fruit thing is going to be the thing that causes most of these browsers to get through. So I should focus my energy on these things in this rank order. And if you're on the offensive side, you want to use this as your sort of hit list of what things I need to include in order to make this browser work. If it has this, then this, then this, it's probably going to work, and anything else on this list is kind of diminishing returns. So maybe I'll go look for someone else to hit. So there is the entire Rube Goldberg machine in one screenshot. Go from some Newsweek post to a bunch of different recordings of web pages, to a machine learner, to a data set, to a dominance analysis, to a bar chart. And the only thing that we care about really is the bar chart. And so there's the bar chart. The idea here is that just using Selenium, something that can run with JavaScript, something that's really basic, is going to drive most of your variation, most of the success you're going to get. And then there's this huge drop off to, are you using headedness or not? Is it actually mounted to a virtual display or not? And then to another degree less, are you trying to hide the fact that this is a Selenium browser or a Python browser or whatever, or a Python HTTP request? So are you screwing with the state of the Selenium instance to make it say, oh yeah, no, this is not robots, this is a very legit guy that lives in a data center in Santa Clara or something. And then almost to no effect does IP obfuscation matter. That was sort of the interesting thing that I found here was, it doesn't really matter if it's coming from low reputation IPs or high reputation IPs when you account for these other things, which really drive the story. The other note here is that the R squared is 0.31, so in like very basic terms, that means that it's picking something up, but it's not picking up the whole story. So I count that to, there's lots of different ways to set up thresholds for these types of tools and design, your particular implementation, and people are screwing with them all the time to make it exactly, miss the cases that they want to let in and not miss the cases that, all of that sort of stuff. So there's lots of variation in this stuff. And even, maybe the same test would work once and not work the next time because there is some element of stochasticity with this stuff. So it's definitely picking up something meaningful here, but it's not picking up everything. And then just as like a sort of top level, this is what it looks like as a more basic data set. We see this huge drop off where only 15% of these requests are successful when we're just sending them through HTTP requests. And it doesn't really matter what we're using, whether or not it's any type of IP obfuscation, it's all pretty crappy. If you're not running JavaScript, they're not going to play. And then it's kind of a wash with the rest of them once we get into this regime of are we using an actual browser or not. There's some that are slightly better than others and some that are worse than others. Residential IP, proxy IPs we see drops on because there's lots of different problems with connecting sometimes and just having weak connections that get dropped, and so some of that's attributable just to that. But yeah, what was interesting, one more interesting thing was in every case for the 200 retailers that I looked at least one browser was able to get through. So that sort of goes to this theory that like, you can block this stuff, but with enough time and with enough specific implementations, somebody will find the hole that you haven't accounted for or that you specifically left open because there's some other vendor that needs to take screenshots of your site to do some sort of thing that, somebody in marketing signed up for. And so now you just have to have this little backdoor, and you just hope that that's not a huge backdoor that people care about that are building these sorts of things. And that's it. I'd love to answer any questions about this stuff or manipulation in general or any of that. Great question. So the question is, what was the sort of methodology of data capture for the original data set? So there's about 10,000 capture is in the data set. It's not just screenshots, it's also, what was the rendered DOM, what was the, what were the headers, the cookies, all of that sort of stuff. What was actually given to me in response to this request, right? One part of it was, what was the temporal nature? Did I do it at a time when people are usually looking for Patagonia jackets or Burlington Coat Factory things or whatever, right? And the answer is no, I ran it when I ran it because I wanted to get this post out. And so, there's some sort of, randomized controlled trial element there because it was, when I did it. So I didn't try to control for that too much. And it was just one-shot attempt to get a resolution from the server. I have internal systems that are able to determine if there was some sort of internal failure on my side that's not their problem, and those are rejected and removed from the data set. And then I also removed any retailer that had fewer than 20% of the responses come back as being blocked by WAFs, because then I'm saying these companies are not meaningfully trying to block this traffic in the first place, so they're not doing enough for this to even be worth looking at whether or not they have a useful strategy, because their strategy basically is not do much. So, sure. So the question is, how deep did this data set capture go? Did you just hit the website once, or did you actually, go in and type a search for Patagonia sweaters or something, right? The answer is it was just a ping on their root site, their top-level domain. That's a pretty non-controversial thing to do with a bot. If you have problems with that, I sort of have problems with it, but we are in an environment where that's totally fine, and that's actually a preferred way of doing things. So whatever. But yeah, it was just hitting the top level and taking a very cursory scan. But yeah, the wager being that if you're not protecting the top level, you're probably not doing much beyond that. That's a loose assumption. There's deeper you go into systems, more in interrogation of the browsers. But yeah.
What data center did you use? If you have a hypothesis of how your data might change if you use a different data center for sourcing your crawls?
Sure. My data center is redacted, and I'm sure that it would change if you used a different data center. I think that data center in turn probably runs on a lot of AWS shit, as far as I can tell, because when you use some of their other products, you're just using AWS. So I don't know if that helps you narrow down which provider it was. But yeah, so I think obviously it's going to change if you're using different data providers. Obviously it's going to change if you're using different data, even whatever, regions on your data provider, right? That might trigger certain events, right? There's maybe more, interrogation if you're visiting a very US website. Like Winco is on this list of companies, and Winco, if you hit Winco from Bulgaria, it's like, no. So that, there's certain things like that. There's quirks like that come up, for sure. Go for it real quick and then.
Yeah, I was wondering if you set any request headers, like a refer or a cookie, and
Nope.
if that might have actually helped you punch through the WAF?
Nope, this is Joe browser coming from anywhere USA.
Do you think it might help? Or?
Yeah, potentially, sure, right? I mean, I think this is there's sort of, tweaks at the margins of all of this stuff that you can do to increase yield, as it were, right? This is sort of the initial test of let's take a very naive approach and assume nothing, and also not do a lot of work of looking up what headers would work for each of these 200 different websites, right? But yeah, totally. There's plenty of circumstances where that would work, and in fact, some web application firewalls, the way that they work under the hood is if you pass the first test, they give you a token, and you can use that token in curl or whatever else you want to use for the rest of the day, and they're like, that looks totally fine to me. So there's definitely implementations that are very prone to that sort of attack. Go for it. Ooh, okay, so there are good bots out on the internet that people think are great, like Google bots and different other non-Google bot competitors, Bing bots maybe, and so the question is, what if you just mimic them? Sounds more illegal, but yeah, I think that you could probably get away with that sort of thing, right? If you were to say, yeah, this is definitely the Google crawler, and maybe make it an IP that is in the same region somehow through fucking with proxies and seeing like, oh yeah, this is also in Mountain View or something. I don't know. Maybe you can do something there. I haven't tried it. That'd be interesting. You probably get some yield on it. Way in the back. So the Google publishes their IPs? Is that what you said? Oh, gotcha. Gotcha. So Google publishes the addresses of the bots. So if you are a sophisticated person, you'd be able to say, this doesn't look super legit because it's coming from a totally weird place that's not that address. So great. Thank you so much. Visit the website. We have tools on there. Give it a shot.